Hello everybody. Today we will continue talking about the matrices, and one thing that we will talk about today is the solution of the linear algebraic equations. And this is a topic that we covered before in Excel series, and this is the example that we solved. So I'll quickly go through the steps, which were pretty simple actually. We had this matrix which we call matrix A. And then we got the determinant to make sure that this set of equations is solvable, and then we got the inverse of the matrix, and then we multiplied the inverse of the matrix with the matrix B, which is the product or the constant, and then the solution was the multiplication of these two matrices. So just to remember how we did this in Excel, we had to first write these in the variables and then to get the inverse we had to highlight all these cells and then to write M inverse and then press Ctrl Shift and Enter so that it understands it's an array operation, and then we did the same for multiplication. So it kind of took some time in Excel, so we'll see how we can do this in Matlab. I'll do the same thing. We first define matrix A, which is 1, -1, -1, 3, 2, 4, 3, 2, 2, 2, 1.5, 1, and 1, 1.5, 1, 2. So this is matrix A. There is the matrix B is the constants, which is 1, 2, 3, 4, and I put the transpose here instead of writing say 3 semicolons. And then we need to get the determinant. So to get the determinant, I'll call it D. It's det of A, which is 7.5. I think there's something wrong. It's 1. Oh, there's -1 here. So it's a good mistake that I did. This should be -1, not 1. So I can say that I want A1. This is exactly what we did last time. Yeah. So we can edit one value in the matrix instead of rewriting the whole matrix again. So the determinant is done. So this is easy here and there, and now gets the best part. If you want to get the inverse, I call it inverse, which is inv of A. And that's it. So it should be the same values. This is 0 and this is 0. So these two are zeros, -0.51. It's almost exactly the same values actually. And then the solution would be x is inverse multiplied by B, and the solution is 272, -92, -7. So it's easier to do this in Matlab here than to do it in Excel. And if any one of you did this in Excel, you know that you have to be very careful while highlighting the cells, and if there's any problem, you have to delete all the cells and highlight them again to make sure that you are solving it right. So the solution of these kind of equations in Matlab is very easy and straightforward. There are other operations that are very useful in Matlab. We didn't talk about them last time, but there are basic operations like addition, subtraction, multiplication, and stuff like that. So I'll clean this, and now let's define a matrix M. It's 1, 2, 3, 4, 5, 6, 7, 8. And then matrix N, or let's see it here, and then matrix N equals, let's say 5, 10, 15, 20, or let's make it 2. Okay, 15, 20, 25, 30, 35, 40. I want to see this. So if I want to add the two matrices, it's pretty simple. Just add these. So addition and subtraction is pretty straightforward. For the multiplication, we know that if I have this matrix is 2 rows and 4 columns, then I have to multiply it by a matrix which has 4 rows and any number of columns, but it must have 4 rows. And if I try to multiply matrices with with this condition not fulfilled, like for instance if I multiply m by n, it's gonna give the error, because it says the inner matrix dimensions, which is the number of columns of the first and the number of rows of the second, must agree. So I can multiply it by n transpose, and here it can be done. So it's 2 by 4 multiplied by 4 by 2, so the solution would be 2 by 2. But there is one other way of multiplying in Matlab, which is not a matrix multiplication. So what we did here is called a matrix multiplication. The other kind of multiplication is called the element-wise multiplication, which is simply multiplying each element with the corresponding element on the other matrix. So if I multiply m by n, so we have here m and n, so I'll be multiplying 1 by 5, 2 by 10, 3 by 15, 4 by 20. It's exactly like addition and subtraction. You multiply each cell with the corresponding cell in the next one. To do this element-wise multiplication, you will just put a dot before the multiply sign, and this is what we see here. Before, when we did it here, it gave an error, but here it could solve the multiplication. And of course for here it's not the inner matrix dimensions that have to agree. The whole matrix dimensions must agree. So this is 2 by 4, then this has to be 2 by 4. So this is one cool thing. One other thing is the raising a matrix to the power. So if for instance I want to raise matrix m to the power of 2, it's not gonna be possible, because it is multiplying m by m. So this will work for a square matrix. So if I define a matrix K, which is 1, 2, 3, 4, I can do k power 2 because it's a square matrix 2 by 2 multiplied by 2 by 2, so the product will be 2 by 2, and the inner matrix dimensions agree. But you can do it for non-square matrices like M with the element-wise power, which is the same as we did in multiplication. So for M now I have M equal or the M, where's M? M 1, 2, 3, 4. So this will be 1, 4, 9, 16, 25, 36, 49, 64. So this is what it does. So the element-wise multiplication, division, multiplication power is very, very useful. You might not feel that it's useful here, but there are very many cases that you will need these kind of things. And this is one thing that you need to keep in mind, is that in this introductory videos, we are not talking about the applications. We are talking about the capabilities of the software and what we can do and how we can do these operations. And then when we need it in the future, we will say, okay, I know this, we did this before. So even if you think it's not as important as anything else, or you're wasting your time, I'm telling you, it may be the bottleneck in one of your files that you need to do this operation, and if you don't know how to do it now, you'll not know how to do it in the future. So we talked about the matrix calculations for the solution of linear algebraic equations. We covered the addition, subtractions, power, and we did know the difference between the element-wise and the array multiplications and operations in general. So I'll stop here and we'll continue the next video, inshallah. I'll see you then.